Alright, so we are going to talk about how to use Excel to do a scatter plot graph, and then also to have the computer program do a linear regression line, or tell you what the equation for the line of best fit is. So once you've entered all your data into Excel, columns, rows, doesn't really matter. You just need your data to be organized in tabular fashion. Click on any empty box in the page. To insert a graph, you go to Insert, and then here are your options for graph type. For science, most of the time we're going to have them do a scatter plot. So you choose scatter. Here are your options listed. You always want to choose the one where it's just points. When you do that, what should happen is you should get a big blank rectangle here. If for some reason there's already a line that's plotted or a bunch of points that are plotted, don't worry, I'll show you how to fix that, but you really want the empty box. You will also notice that when you are clicking in the box, this green tab shows up at the top. The only way you can modify the chart is if this green tab is available. If for some reason you accidentally click outside your graph at some point during the activity, you'll notice the green box went away. To get it to come back, click back on the graph. Oh look, there it is. So, there's no data right now, we need to add data. So over to the side here, we choose Select Data. If there were already points on your graph that you wanted to get rid of, they would be listed in here. You would hit Remove as many times as you needed to until this entire screen went empty. Once it was emptied, okay, now we got to give it new values. So what do you want to call the first series? Well, this was my heart rate. So I'm going to call this first series Miss Vote. Then you have to tell it what are the X numbers, what are the Y numbers. So for the X values, over here on the right, this little button, when you click on it, Edit Series minimizes. And what you're going to do at that point is go over to the numbers you want to go on the X-axis and click and highlight them. So time is our X variable. 1, 2, 3, 6 data points there. And when you highlight it, the box will flash around it. Don't worry about the dollar signs, the exclamation points and stuff over here. It's computer programming code. You don't have to understand it. And when you're done, you click on that button again on the outside. So that's our X values. Now we need to tell it our Y values in a similar process. So we click on this little button here. It minimizes. We click on the Y values. Flashing dotted box around it. Don't worry about the terminology here. Click on that button. Okay. At this point in time, I'm done for this particular lab, but if you measured, a bunch of different people's heart rate, and you wanted to enter in not just Ms. Votes, but Johnny's or Sally's or whoever else's heart rate, for every person or every trial, you keep hitting Add. And you can see here, the first set of points was diamonds that were blue. Well, the next person might be red triangles, and the next person might be green circles. You could add an entire class worth of trials, and every single person would be a different color and or a different shape of point. And so you could kind of plot to look for trends, not just in one person, but among males, among females, among the whole class, among athletes, whatever you wanted. So you just keep hitting Add for every trial you had. So we hit OK. There's our graph. Things we need: axis, title, some kind of line to connect the points. So now we're done with the design. Now we're going to change the layout, little details. So you click Layout up at the top. To give the chart a title, just kidding. To give the chart a title, this is aesthetic preference. I like above. We are going to call this, heart rate versus exercise duration. Call it whatever you want, but make it meaningful. Then we need to label the axis. So axis titles for the horizontal axis. That was seconds when on our horizontal axis. Seconds. And then axis titles vertical. These are all aesthetic choices. I like rotated. This was heartbeat per 10 seconds. So that's nice. We've got a title. Our axes are labeled. What's nice about it is Excel is that it auto scales it for you. But now it'd be nice if we knew the equation for the best fit line. Kids are going to be able to look at this and obviously tell that it's a direct relationship, a linear relationship. But if we knew the equation for that line, we could quantify and talk about, okay, what does the slope mean? What is the y-intercept? What is its actual physical meaning? So a couple ways you can do that. To add a best fit line, you can either right-click on one of the points and select Add Trend Line, or just as easily, up here at the top, where it says Trend Line, if you click on it, here's your options. This is obviously similar to a straight line, so we're going to choose Linear Trend Line. If you had any kind of curve, square, square root, cubed, whatever, you would choose this option. But this is a straight line, so Linear Trend Line. And as soon as you do that, look, here is a black line. That is your line of best fit through your data points. And you can see this one is above, these are kind of below, but this is the best approximation of the average of those points. Now we need the equation for it. It's not automatically given. So to get the equation for the line, you right-click on it, Format Trend Line. Here, this is important, these three little buttons down here. If you know for certain that when it should go through the origin, you would highlight this. In this lab, we don't want to say that, because if you had a heartbeat of 0 for every 10 seconds, that means you were dead. So at no point should your heart rate hit 0. But if you were measuring density, where mass and volume, if you don't have any volume, then you don't have any mass. Like if it's not there, it's not there. You could click this, and basically if you check that button, it just makes sure that if it should go through the origin, it will. Like that is the one point where that won't be, hopefully it makes it on the line of best fit. The line of best fit will start there and then do its best from the origin out to the edge. But we don't need that here. We want to uncheck that. These two we want to check though. We want the equation, we want the r squared value. R squared is pretty straightforward. R squared is just a measure of how precise were your measurements. So were your points close to the line of best fit? You want an r squared that is really close to 1 or negative 1. The closer it is to 1 or negative 1, the better your precision. And once you've checked those two boxes, you hit close. And there's your equation for your line. And so at that point, okay, we've got an r squared of 0.98. That's pretty close to 1, so pretty good linear regression line. That's a pretty close to an actual linear relationship. And our slope is 0.1857, and our y-intercept is 12.33. And so y equals mx plus b, and then you can be asked questions about and answer questions about what is the slope showing, what does the y-intercept mean, things of that nature. But that's how you get Excel to not only give you a scatter plot, do a linear regression, and then give you the equation of the line and the statistical information about it.